This is our 2014 higher level surface geometry question. It's question C3 on section C. The question is based on a pentagon. We have a pentagon to draw and plan, side 30 meters, and then we're going to project the elevation. Part A, we have to draw the regular pentagon and complete the given plan and elevation of surfaces A and B. So our first two surfaces A and B are here. We're not worried about surface C. The scale, 1:500. We convert all our measurements to millimeters. So 30 meters multiplied by 1,000 is 30,000 millimeters. So we have to divide 30,000 divided by 500. It becomes 60 millimeters. 6 meters becomes 12. 12 meters becomes 24. And 24 meters converts to 48 millimeters. So we've only 4 measurements to set out on the drawing. We start off the plan. 60 millimeter base. Draw a 72 degree angle. So out the side we've got a 72 degree angle here to set up our pentagon. And then we just strike a 60 millimeter arc each side. Our XY line touches the apex of the pentagon. And then we can project up each of our points into elevation. We only draw A and B for the time being. We don't need part C, or surface C. Part B of the question, we determine the dihedral angle between surfaces A and B. So again, we've got our two surfaces A and B. I've set up the question on the sheet. I've only drawn in and highlighted surfaces A and B. Labeling the points. We've got point 1 in elevation and plan, points 2 in elevation and plan, 3 in elevation and plan, and 4 in elevation and plan. So we're only dealing with 4 points. It's pretty straightforward. Dihedral angle is the same all the time. Auxiliary elevation, auxiliary plan. Our auxiliary elevation, we have to look in at 90 degrees to the line of intersection. Here is our line of intersection. I need to draw an auxiliary elevation looking in at 90 degrees to that line. So my line of sight is going to look in this direction, in here. So I'm going to project my drawing up here. I could project it in the opposite direction, but it'll go off the page on me. So set up my auxiliary elevation at 90 degrees. XY line will just come out parallel. And I'll project out the 4 lines 90 degrees to that line. This is our X1, Y1. Make sure you label it. This is an auxiliary elevation. So I'm drawing an auxiliary elevation. I need to take my heights from elevation. I deal with the previous XY line. I'm just after drawing X1, Y1, meaning I'm going to measure from XY. So for my auxiliary elevation, I take my heights from the XY line into elevation. Height to point 1. We strike it off. Measure up, we get the height to point 1. Height to point 2. Follow point 2. Point 3. Follow point 3. Sorry, that's 3. And 4 is the same height because we've got a horizontal line in elevation. 3 and 4 are there, close together. The line of intersection, which is the important line, is line 2, 3. So we've got the true length of that line when we looked in at 90 degrees to it. 2, 3, 4 is the one we're going to see most of. 3 and 4 is the horizontal line. Make sure you draw it as a horizontal line. In other words, it's parallel to the XY line. Otherwise the drawing won't look right. And then 1, 2, 3 is my other plane. I made a slight mistake by accident just joining the line to the round point. So it was lucky that I labelled the points. My line of intersection is 2, 3. And I've got the plane 1, 2, 3, which is plane A. and plane B in red is 2, 3, 4. That is my auxiliary elevation drawn. Now I need to draw my auxiliary plan, and the auxiliary plan looks along the line of intersection. My line of intersection is 2, 3. I look along it. So I'm looking in this direction here, looking down along the line of intersection. I've got my line of sight set up, so I can set up my XY line as close as possible to it, but not up on top of it. And again, straight away, label it. It's an X2, Y2. Project each of my lines of sight parallel to that first line. So point 4 comes down, point 1 comes down. Again, same rules apply. I'm drawing an auxiliary plan, so I need to take my measurements from plan. I've just drawn the X2, Y2 line, so I work from the previous XY line, which is X1, Y1. So the measurements I need to take are from my X1, Y1 line into my plan view. I mightn't need a datum line. I'll just check. It's pretty big and it's going off the page on me, so I will use datum line. So I just pull back the XY line closer to the drawing, anywhere at all, and I can put in a datum line. So it's a reference line. So instead of having to take the larger measurement, I can now shorten up each measurement. So from my datum line to point 4, strike it off in plan. Strike off my distance. Datum line to 3, and bring down point 3. Datum line to point 2 is the same measurement. We follow down point 2 and it's the same measurement. So 3, 2 ends up in the same place, which is what I want. And my last measurement, datum line to 1, and we bring out point 1. I have to extend the XY line there a bit and take my distance and strike it out. And that gives us our dihedral angle, because now plane 1, 2, 3 looks like a line and plane 2, 3, 4 looks like a line. Always indicate the dihedral angle. We're going to skip on to part D of the question, because it's very similar to part B. It's basically the same process. The dihedral angle between surfaces B and C is 160 degrees. Complete the projections of surface C. So we know that the dihedral angle is 160 degrees, meaning we can use that. As soon as you hear dihedral angle, you'd automatically be thinking auxiliary elevation, auxiliary plan, like we'd normally do it. We're missing point 5 that I've labelled up here in elevation. I have surface B in elevation and plan. I don't have surface C in elevation and plan, meaning I'll work with surface B. We said the process is the exact same: auxiliary elevation and then auxiliary plan. So if I was doing the dihedral angle like I did it over here, I'd do an auxiliary elevation looking at the line of intersection. Line of intersection between B and C is here. So you can build this question up piece by piece. Even if you don't know exactly how to do it, you know the method and you can try and do the auxiliary elevation and see how far you get. Looking in at 90 degrees. So I need to project a line of sight in here at 90 degrees to the line of intersection. Something like that. So I start off with that. Project out my XY line. And again, it's an X1, Y1. It's a new set of drawings, so it's an X1, Y1. My lines of sight are projected out at 90 degrees. So I'll project out the points on surfaces B and C. Heights are taken from elevation. It's an auxiliary elevation, so the heights are going to be taken from elevation. Height of point 2. We have it. Point 2. Height of point 3 and 4 are the same. So height of point 3 is here, and height of point 4 is here. I've projected out point 5, but I don't have a height for it, so I can't draw it in as of yet. I can draw in surface B, and again line 3, 4 is horizontal, so make sure it's parallel to the XY line. That is my surface C drawn, but I'm obviously missing 0.5. I'll go now and draw the auxiliary plane. So I've got my red surface, surface B up here. Same rules apply. I'll come along and draw my auxiliary plane. So I've got my 3 points. In elevation, I need to look along the line of intersection. Line of intersection is line 3, 4. Look along line 3, 4. Remember, that was a horizontal line, so it should be projected out looking along 3, 4, which should be parallel to the XY line. Set up an XY line at 90 degrees. I can set it up here anywhere, it doesn't really matter. X2, Y2. And again, straight away, it's an auxiliary plane. So I'm going to be measuring from plane, and I'm going to measure from the previous XY line. Again, my distances are large, so I'm going to pull in the XY line a little bit. Back in here, and I'll set up a datum line, a new datum line. So they're like separate questions. It's nothing to do with the last question, my datum. And again, the same method. Distance to point 2, and I project out point 2. So my distance, just to recheck it, follow point 2 out, strike it off. 3 and 4 have the same measurement. 3 and 4 have the same measurement. Project out points 3 and 4, and they'll end up in the 1 position. That gives me an edge view of the plane. Back to the question, it said our dihedral angle is 160 degrees. I have an edge view of plane B, meaning that I can come along and draw in the dihedral angle of 160 degrees. Now, there's a little bit of a problem here in that I've got 2 options. I can draw 160 degrees in this direction, or I can turn up the other way and draw 160 degrees in the other direction. So 160 degrees around to here. And we need to figure out which is the correct one. To do that, 0.5 in the question is slightly above 3 and 4 in elevation. So in other words, when I have my original elevation, I project up 0.5. It's up here someplace. It's higher than 3 and 4. Meaning, in my auxiliary elevation, which we have here, when I project out 0.5, 0.5 will be up here someplace. If I project 160 degrees back in this direction, the point will end up in that area. So I've drawn in my dihedral angle of 160 degrees. and it's here. So 160 degrees around this direction. But I don't know exactly where 0.5 is. It's going to be somewhere here, but I don't know where. Again, this is an auxiliary plan. And we've transferred measurements from our original plan to the auxiliary plan. So in other words, I took the distance for 4 from the datum line to 4, and I transferred it into auxiliary plan. Now we can do the exact same thing, the distance to 5. Here's my distance from the datum line to 5, and I need to transfer that distance into plan. To do that accurately, you just take any point out from the XY line. So anywhere at all out from the XY line, I'll just measure out at 90 degrees. So I've just taken a random construction line out. The distance is from datum line to 5, and I set out that distance in my auxiliary plan. So I've just copied the distance across. 0.5 has to be somewhere along this line because it's going to be an edge view of plane 345. So I just transfer that measurement over. So parallel to the XY line, and here is 0.5. So what that gives me is 0.5, my measurement from XY line into the view. It's just accurately done. Now that I've got 0.5, I've got a completed dihedral angle. So here's my dihedral angle. I've got my edge view of plane 345, and now I can bring that point back in through the views. So I'm basically, instead of projecting points out to auxiliary plan, I'm going to project from auxiliary plan back in. Remember, I projected out 0.5 originally, but I didn't have a height. When I project 0.5 back in parallel, so from auxiliary plan, I'm going to project 0.5 back in. Now I've got 0.5 in my auxiliary elevation. And that is plane C in green. I'm still missing it in the elevation. Again, I projected 0.5 up to elevation, but I didn't have a height. But once again, auxiliary elevation is here. This is an elevation. I transferred heights from elevation to auxiliary elevation. So the opposite can happen. I can take the height 0.5 and transfer it to my original elevation. So there is 0.5 in the original elevation. And that lets me complete the drawing. That's C in the elevation. And that gives me the plane. The part C we're going to leave. That was to do with the vertical and horizontal traces. I'm not going to throw that into this question because it's going to confuse things. We'll leave it at that because you have a dihedral angle question and you have a very similar dihedral angle question. If you can do both of those, you'll be doing well enough. Okay, give it a go.